Hey, on this video, we're going to be talking about area of a sector of a circle. Now, just to give you a little quick idea of what it would be. So, think of yourself as eating a piece of pie or a piece of pizza. We're trying to see what exactly this amount of slice would be. How much do we actually get from our piece of pizza? So, the idea right now is we're going to be looking for how much of a slice am I going to be getting. So we're going to go ahead and list out some of the formulas so you can go ahead and see what they are. They're exactly the same, just depending on what you're given. So if you're given degrees, this formula may help you. If it's given to you in radians, this other one will help you. But remember, if you're given degrees or radians, it shouldn't matter. None of these formulas should matter because you should be able to convert between degrees and radians. So knowing both of them would just help you overall. So the first one I'm going to talk about is the one for degrees. So the one for the degrees is the area of a sector would look like pi r squared. So you're going to use essentially the area formula for a whole circle. And then what we're going to do is we're going to multiply that by theta over 360. Meaning that that would be the specific angle or the specific piece of the pie we're looking for. So that's what the formula would look like for degrees. For radians, we would get the area of a sector of a circle would look like 1/2 r squared theta. It'd be essentially the same thing as what we were doing with finding arc length of them, but this is how it would be written. So these are the two formulas. Remember, one would be for radians, the other one would be for degrees. So let's go ahead and see a practice problem, and we'll take a look at how we can compare them. All right, so I'm going to be looking here at number 8. So what is the area of the sector EFG? So if you notice from what the problem looks like, we're trying to see what could happen for the area. Oops, let me undo this actually. Delete. There we go, much better. So we're looking for how much this would be. So we're trying to figure out how much of the piece of the pie that we're looking for inside of here. And this would be the point EFG. So this would be our combination of EF and G right here. So it tells us that the radius is 10. It's telling us that from the outside. And then it's also telling us that the actual arc length of the inside is 120. So we actually know that the distance from here to, or the angle that's produced from here to here, sorry, not distance, is 120 because this is also in here is 120. So since they give it to us in degrees, I'd rather use the other formula just because it'd be simpler for us. Using it in the same units is what I would say. So we call it area of the sector is equal to pi r squared, which that's the circle formula. And then now we'll go ahead and say theta over 360. Now this will help us calculate the actual sector of what we're looking for. So then we'll go ahead and place the information that we know. Well, pi stays there. The 10 is squared. And then from here we get to say 120 over 360. So then we'll know that AS is equal to 100 pi. And then just to bust out the calculator at this point. Sorry, y'all. I'm always bad at mental math. Ain't no shame in it. We multiply that by 1/3. Now from here, we go ahead and multiply. So then we get 100 over 3 pi. And I'm going to leave it like that for now because most of the books will ask for in pi. But if you wanted the actual degrees or you wanted to see what the actual value of it would be, give me 1 second. 104, there you go. So the approximation of this would be 104.72. Doesn't really tell us much. That's why I'm just gonna go ahead and leave it in degrees. Some upcoming videos, you'll go ahead and see more examples of this and working it backwards. Essentially, if they give you finding radius, finding the degrees. So we'll see some more practice problems like that. Thank you very much for your time.